Ninth Standard Maths Part First Lesson number 2 Real Numbers. Now the number system. Natural numbers. Natural numbers set is denoted by capital N and it is given by 1, 2, 3 dash dash. Whole number set. Whole number set is denoted by W and it is given by 0, 1, 2, 3 dash dash. Integer set. Integer set is denoted by capital I. It is given by dash dash -3, -2, -1, 0, 1, 2, 3 dash dash dash. And rational numbers. The number which can be written in the form of P upon Q, where P is any integer and Q is non-zero integer, is called as a rational number. Rational number set is denoted by a Q and it is written in curly bracket P upon Q. P comma Q belongs to I. Q not equal to 0. This is in set builder form. Set Q is a set of all P upon Q such that P comma Q belongs to capital I, Q not equal to 0. Such a set in which numbers are in the form of P upon Q and where P and Q are integers but Q not equal to 0. Q is a non-zero integer. Such numbers are called as a rational numbers. Now we have one more set, that is real number set. Real number set is denoted by capital R. The numbers which can be represented on the number line, that set of numbers is called as a real number set. From this, we can see that the natural number set is subset of whole number set. Whole number set is subset of integers. Integers is a subset of rational numbers and rational numbers is subset of real numbers. So real number set is a universal set for all these numbers. Now let us see about rational number, that is order relation of rational numbers, that how to compare these rational numbers we have studied in 8th standard. If P upon Q and R upon S are two rational numbers such that Q is greater than 0 and S is greater than 0, that is Q and S are non-zero integers, then if cross product P into S is equal to cross product R into Q, then P upon Q is equal to R upon S. If P into S is greater than R into Q, then P upon Q is greater than R upon S. If P into S is less than R into Q, then P upon Q is less than R upon S. This is called order relation of rational numbers. Now properties of rational numbers. Properties of addition. If A, B and C are rational numbers, that is that numbers are in the form of P upon Q, then we have A plus B is equal to B plus A. That is, order is not important in addition of rational numbers. This property is called as a commutative property. And if there are three rational numbers and then in first bracket A plus B plus C is equal to A plus in bracket B plus C. Here we interchange, we put bracket for first two rational numbers and here we put the bracket for second and third rational number. So interchange of brackets, that is we do first addition of A plus B and then add C in it, and here we do at first addition of B plus C and then add in add a in it. This is called as a associative property. Now a plus 0 is equal to 0 plus a. If any number is added to the rational number, if 0 is added to rational number, then its order is not important. That is, rational number plus 0 is equal to 0 plus that rational number, and addition of 0 in any rational number does not change its value. This is called as a additive identity, and 0 is called as a identity element for addition. If a plus minus a is equal to 0, this is called as a additive inverse. Minus a and plus a are additive inverse of each other. For example, 5 and minus 5 are also additive inverse of each other. So we write minus 5 plus 5 is equal to 0. Now properties of multiplication. There are also four properties. If A, B, C are rational numbers, then the commutative property is A into B is equal to B into A. So order of multiplication of rational numbers is not important. And here the associative property, we have taken multiplication first b into c, and here taken multiplication first a into b. This property is called as a associative property. A into 1 is equal to 1 into a is equal to a. If any rational number is multiplied by 1, its value does not change. This is called as a multiplicative identity, and 1 is called as a identity element of multiplication. A into 1 upon a is equal to 1, where a not equal to 0. This property is called as a multiplicative inverse. Number and its reciprocal are the multiplicative inverse of each other. For example, a and 1a are the 1 upon a. A and 1 upon a are the multiplicative inverse of each other. For example, 1 upon 5 and 5 are the multiplicative inverse of each other. These are the properties of rational numbers. Decimal form of rational numbers. We know that rational numbers are in the form of numerator and denominator. If we divide numerator of rational number by denominator, we get decimal form of that rational numbers. Now these decimal forms are of two types: terminating decimal form and non-terminating recurring decimal form. If we divide numerator of rational number by denominator and we get remainder as a 0 and process of division stops there, then that form is called as a terminating decimal form. For example, 2 upon 5. If we divide 2 by 5, then we get the quotient 0.4, and here remainder is a 0. Then this 0.4 is called terminating decimal form of rational number 2 upon 5. For example, 101 upon 8 is a rational number, and if we divide 101 upon 8, we got 12.625 as a quotient, and remainder in this case is also 0 and process of division stops there. Then 12.625 is called as a terminating decimal form of rational number 101 upon 8. Now what is meant by non-terminating recurring decimal form? If we divide the numerator of rational number by denominator and we does not get remainder as a 0 and process of division does not end there, and digit or group of digits in quotient goes on repeating, then that form is called as a non-terminating recurring decimal form. For example, 17 upon 36 is a rational number. If we divide 17 by 36, we get 0.47222. Here 2222 goes on repeating. Therefore, this 2 is called as a recurring, and recurring number is denoted by one dot on its top. Therefore, 0.472 dot. This form is non-terminating recurring decimal form of the number 17 upon 36. For example, 56 upon 37 is a rational number. If we divide 56 by 37, we get 1.513513 dash dash. Here 513 goes on repeating. The digits are recurring digits, and we write bars on the 513. So we read 1.513 bar here. So 1.513 bar is non-terminating recurring decimal form of the rational number 56 upon 37. If prime factors of denominator of rational numbers are 2 or 5 or 2 and 5 both, then decimal expansion is terminating, otherwise it is non-terminating. So decimal form of any rational number is non-terminating or terminating. This can be identified by its denominator. If the prime factors of denominators are 2 only, or 5 only, or 2 and 5 both, then its decimal form is a non-terminating. Other decimal form is a terminating, otherwise it is non-terminating. For example, let us see 2 upon 25. This 2 upon 25, 25 can be written as 5 into 5. Therefore, this uh, decimal form of this rational number will be terminating. Now 3 upon 16, 3 upon 16 can be written as 16 can be written as 2 into 2, 4 into 2, 8 into 2, 16. Therefore, here in the denominator, the factor is a 2. Therefore, this terminating decimal form. 22 upon 10. This 10 can be written as 5 into 2. So in the denominator, prime factors are 5 and 2. So its decimal expansion is also terminating. Here 3 upon 11. 11 is other than 2 and 5. Therefore its decimal form is non-terminating. Practice set 2.1. Question number 1. Classify the decimal form of the given rational numbers into terminating and non-terminating recurring type. We know that if the prime factors of denominator of rational number are 2 only, or 5 only, or 2 and 5, then its decimal form is terminating decimal form. Otherwise, it is non-terminating recurring type. Now question number 1, 13 upon 5. 13 upon 5, see the denominator is a 5. Therefore, its decimal form is terminating. Terminating. Now 2 upon 11. Denominator is 11 other than 2 and 5. Therefore, its decimal form is non-terminating recurring. Now 29 upon 16. This 29 upon 16 can be written as 16. 2 into 2, 4 into 2, 8 into 2, 16. So denominator have prime factor 2. Therefore its decimal form is terminating. Example number 4. 17 upon 125. This 125 can be written as 5 into 5 into 5. So denominator have prime factor 5. Therefore decimal expansion is terminating. 11 upon 6. This 6 can be written as a 3 into 2. Denominator has a prime factors 3 and 2. Therefore, this is a non-terminating. Recurring time. Question number 2. Write the following rational numbers in decimal form. Example number 1. 127 upon 200. In order to convert this rational number into its decimal form, we have to divide numerator by denominator. Therefore, here we divide 127 by 200. 127 is less than 200. Therefore, quotient is 0 minus 0. That will be 127. Point. Take 1 0. Here we take 0. Now 200 into 6. 1200. It will be, remainder will be 70. Take more 0. 700. 200 into 3. 600. So what will remain is 100. Take 1 0. It will be 1000. 200 into 5 will be 1000. It will be 0. So remainder is a 0 and process of division stops. Therefore, this decimal form of rational number is terminating decimal form, and we write 127 upon 200 is equal to 0.635. Now the next example is 25 upon 99. So divide 25 by 99. 25 is less than 99. Therefore we write 0 point. Here minus 0, that is 25. Here 25.0, take 1 0. 99 into 2 is 198. 198. 250 minus 198. 8 minus 10 minus 8. 2. 10. 15 minus 10 is 5. There is a 0. Take 1 0. 99 into 5, that will be 495. So what will remain here is 5. 12 minus 10 is a 2. And here we got 25. So remainder 25. So the quotient will goes on repeating as 25, 25, 25. So we write 25 upon 99 is equal to 0.2525 dash 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 is equal to 0.25 bar. Question number 3. Write the following rational numbers in P upon Q form. Example number 1 is 0.6 dot. Now let us solve this example. Let x is equal to 0.6 dot. Here only one number is recurring. When only one number is recurring, we multiply both sides by 10. If two numbers are recurring, we multiply both sides by 100. And if three numbers are recurring, we multiply both sides by 1000. Only one number is recurring. Only one number is recurring. Therefore, multiply both sides by 10. Now, this is equation number 1. X into 10 will be 10x is equal to this 0.6 dot is equal to 0.6666 dash dash. And if we multiply this 0.666, then we get 6.666 dash dash. That will be 6.6 dot. Therefore, 0.6 dot into 10 will be 6.6 dot here. Now this will be equation number 2. Now subtract equation 1 from equation 2. Subtracting equation 1 from equation 2, therefore 10x minus x is equal to 6.6 dot minus 0.6 dot. Now let us see 6.6 dot minus 0.6 dot. 6 dot will get cancelled. 6 minus 0 will be 6 there. Now 10x minus x will be 9x. 9x is equal to 6. Therefore x is equal to 6 upon 9. Therefore x is equal to, dividing numerator and denominator by 3. So it will be 2 upon 3. Therefore 0.6 dot is equal to 2 upon 3. Thus we have converted this number into rational number. Now example number 2. Here two digits are recurring. Now let x is equal to 3.17 bar. Two digits are recurring. Therefore, multiply both sides by 100. Multiply both sides of equation 1 by 100. So 100 into x will be 100x is equal to, now 3.17 bar is a 3.1717 in this way. And if we multiply this by 100, then we get 317.1717. That is 317.17 bar. So we get here 317.17 bar, which is equation number 2. Subtracting equation 1 from equation 2. Subtracting equation 1 from equation 2. Now 100x minus x, 100x minus x is equal to 317.17 bar minus 3.17 bar. 100x minus x will be 99x. Now 317.17 bar minus 3.17 bar. 17 bar will get cancelled. This will be 314. Therefore 99x is equal to 314. Therefore x is equal to 314 upon 99. Therefore 3.17 bar is equal to 314 upon 99. Now example number 5. Let x is equal to 2.514 bar. This is equation number 1. Now here 3 digits are recurring. Therefore we multiply equation number 1 by 1000. So we write 3 digits are recurring. Therefore multiply both sides by 1000. Therefore 100 into x will be 1000x is equal to, now 2.514 bar can be written as 2.514 dash dash. If we multiply this number by 1000, we get 2514.514 dash dash. That will be 2514.514 bar. Therefore, here we write 2.2514.514 bar. This is equation number 2. Now subtract equation 1 from equation 2. Subtract equation 1 from equation 2. Therefore 1000x minus x is equal to 2514.514 bar minus 2.514 bar. 1000x minus x. 2514.514 bar minus 2.514 bar. Here 2.514 bar minus 2.514 bar. So what we'll get? This 514 bar and 514 bar will get cancelled. 14 minus 2 is a 12. Therefore we get 2512. And 1000x minus x is 999x is equal to 2512. Therefore we get x is equal to 2512 upon 999. Therefore, 2.514 bar is equal to 2512 upon 999. So this is P upon Q form of this number.